Okay. Thank you very much. Much better. Much better. All right. So without further ado, okay. Title of this talk is Java E7 in action. The title is actually significant. So I think most of you here have at least heard of Java E7 or maybe are aware of Java E7 a bit. So obviously at this stage, doing a very basic tutorial, lecture-oriented talk, sort of what we call in the speaker terminology, bullet-ridden slides. It doesn't make any difference. That's not the thing to accomplish at this moment. So what is it that I'm going to do differently? Well, the difference is the format of how I'll be doing this tutorial. Basically, in this tutorial, I'll be talking a bit about Java E7. Of course, I'll be doing a little bit of API coverage, same as you would in a bullet-ridden slide format style talk. But in addition, what I'll be doing is actually showing you Java E7 code in a realistic running application. That's what the in-action part comes in. And that's a bit different. It gives you a little bit of perspective of how these APIs will actually be used in a real application. It gives you a bit of context about use case. And I think more importantly, it gives you a resource that you can take a look at later. And in fact, the application that I'll be using throughout this tutorial is publicly available. I'll introduce that in just a second. And it is available for that reason, so that you can actually play around with Java E7 in a realistic application and use all of these features in context if you will. Okay, so all of that aside, if you're not familiar with who I am, my name is Reza Rahman. I'm a Java evangelist at Oracle Corporation. Up there, of course, is my email address and Twitter handle. Do make use of that. In addition, though, keep in mind that one of the value propositions of you being here and me being here at the same time with you is that we can chat one-on-one in person. So do take advantage of that time. I will be around for the next couple of days. So if you have any questions on the tutorial or Java E7 or Java E generally, this is the time to have those conversations. And certainly we could take those conversations further after I leave the venue. All right. So how do I plan to spend the time that we have? About 178 more minutes, according to the time stamp that I have going on. This is my general plan. Okay, so I'll be spending a little bit of time doing an elevator pitch of Java E7. I will be taking a look at Java E7 at a relatively high level. So if you will, manager speak, the same conversation about Java E7 maybe you ought to have with your manager. And then we'll be diving into this application that I'll be using sort of as a tool, as a learning tool throughout this tutorial. The application's name is Cargo Tracker. I'll familiarize you with what that application is in just a second. And then finally, a majority of this talk is actually going to be deep dives of specific Java E7 APIs, again, following the general format. Talking about, okay, this is what this API is, this is what these feature changes are, and showing you some of those features in a realistic application. Obviously, in 3 hours, or in fact, even in a day, it wouldn't be possible for me to show you every single feature. In fact, the application doesn't contain every single feature of Java E7. I will be talking about a good representative set of features, though, and the parts that I won't is actually color-coded, and I'll get to that in a second when we start taking a look at the slide decks. Now, a couple of things that I want to get out of the way in this tutorial before we go too far forward. Number one is I realistically do not plan to cover my entire slide deck. I have about quite a bit of material. I think the material is very easily around 4 or 5 hours. What I will aim to do instead is cover at a decent pace, understandable pace, as much material as I can. But I will give you all of the tools necessary so that you can teach yourself going forward. In fact, you'll be able to go through the material without me, by and large, I hope. The second thing I want to go over is that I do want to do Q&A concurrent with the session. So it's a 3-hour session. You don't need to hold your questions until the very end. I will stop and queue you, to ask me questions. But regardless of that, do be very proactive. If you have a question, raise your hand. The room's kind of dark, but I think I can still see most of you. You'll have to yell a bit louder if you're out in the back, but I will repeat the question. So certainly don't be shy. Let's make this tutorial more of a conversation rather than me simply lecturing. That would be a good goal accomplished if I can get to that. All right. So what is in Java E7? These are the principal themes of Java E7. They are productivity, HTML5, and enterprise demands. We should talk about each of these in turn. Productivity is an obvious one. This is our foremost priority and has been since Java E5 in the platform. We want to make sure that every single API that we have and the API and the platform as a whole is as easy to use as possible. So we're always looking for ways of making things easier, faster, less code, and the like. And we did a bit of that in Java E7 as well. The good news is there wasn't really that many places where we needed to do that. The biggest example is actually going to be JMS 2.0, and I'll start my talk with JMS 2.0. It's a good starting point to sort of continue the theme of productivity that we want to keep moving forward. But okay, we do mean that. In reality, we've had a lot of FUD over the years about productivity in Java E, so that's always going to be a focus, and it's most certainly a focus in Java E7 and Java E8 and moving forward. HTML5 is also a big theme, and it also bears a bit of explanation. So the great news for all of us is that the web standards, so for things that come out of standards bodies like W3C, those things are finally moving forward, and it's about time. We really needed that to occur. We, as if you will, a sister spec of these important web standard specs, absolutely want to make sure that you, as server-side Java developers, are 110% ready, okay, to take advantage of all of these features. So we've taken a look at all of those things and make sure that they are usable within the Java E platform. There's a lot of examples of this. I would say a good amount of work has been done in Java E7 in this regard. Some obvious examples are things like WebSocket and the JSON support, which we'll talk about in a second, but there's a lot more. In fact, I'd say almost every single web-facing API have had some sets of changes that are geared specifically towards making you, enabling you to make use of these innovations that are happening in the web standard space. And finally, enterprise demands. This, again, is an obvious one. At the end of the day, we are an enterprise platform. We want to make sure that our core customer base, our core user base, which is folks in blue-collar IT organizations, doing perhaps very vanilla things, but very important things, have the tools that they need to succeed. So in Java E7, there are some examples of these as well. The most obvious example is probably the batch application API, but there are some others. So there's things like the concurrency utilities for Java E that also squarely fall on this blue-collar enterprise IT space. All right. Bird's eye view of what precisely is in Java E7. Hopefully you've seen this graphic before. If you haven't, this is a good API. It's a good place to get started with Java E7. As you can see, the graphic is color-coded. There's, by and large, 3 groups of changes that occurred in Java E7. And this is true of generally of Java, every single Java E release. Some new APIs that were added. So these are brand new use cases that the platform now supports. So the examples of these would be the concurrency utilities for Java EE, the batch applications API, Java API for JSON, and Java API for WebSocket. As you can see, batch applications, we said, and concurrency utilities are more towards the enterprise space. The JSON support, as well as things like WebSocket, clearly is more along the lines of HTML5 support. And we have a few APIs that have gone through significant revisions. So these would be JAX-RS 2.0, EL 3.0, and JMS 2.0. Okay, and basically the distinction between this and a minor release is the amount of changes that have gone through each of them. JAX-RS, again, a large majority of the changes here is sort of HTML5 enablement. EL 3.0, we'll talk about that if there's time. It's sort of long pending changes that needed to happen with the EL 3.0 finally coming about. JMS 2.2, as I said, is principally first and foremost about productivity. All right. Beyond that, you will notice that a large portion of this graphic is actually devoted to minor, quote-unquote, minor releases, things that are point releases of various APIs. I actually think the most important part of Java EE actually lies in these APIs. Although you might think it's a point release, what have you. When you actually dive into some of these point releases, each of these point releases actually have significant, important features critical to the usages of each of these APIs. Okay, so that alone, frankly, is enough reason to upgrade to Java 7 in my mind. And also, visually speaking, what you'll realize is that these sorts of changes, the point release changes, actually outweigh the amount of changes that are in the new APIs and the major updates, if you will. Okay. In fact, what you'll notice is that in this particular Java 7 release, we've actually updated almost every single major API in the platform. So this is a large release. It's very easily the largest release that we've had in the platform for a very long time. All right. So this is very significant, and of course, beyond all of that, we have our extensions and ecosystem around Java EE. This is always important and always worth reminding ourselves. So these are things like Archelion, Delta Spike, Prime Faces, all of the things, neat things that build upon Java EE APIs in meaningful ways. We certainly don't want to forget about them. Okay. Yes. Good, excellent. We already have a question. Yes?
Yeah, well, a small thing. I think with G7, you also started to deprecate APIs, right?
Correct. Yeah, there are some API deprecations. They happened in Java EE6 as well. We did a bit of that in Java EE7. The big deprecations in Java EE7, I believe, were the JAX-R API, as well as some of the older EJB2 APIs. So yes, there's a bit of that as well.
I think it's really important to clean up the old bits.
Uh-huh.
Otherwise, it only gets bigger.
Yes, we've been doing that, and we'll do that also going forward. You know, we're looking to deprecate some other things in Java EE8 as well. Okay. Any other questions? Since we have a question anyway. No? All right. Moving forward. So this is a bit, I guess, a bit of more new news I can share with you now. This is available Java EE7 platforms that we have now. Okay, so this is getting better and better, and it will continue to grow, but it's already fairly impressive. There's not many other standards, short of things like SQL, that have quite this many successful implementations behind them. This is very unique in my mind for Java EE, and these are all active, readily available, usable choices in terms of Java EE7 implementations. Wildfly and Glassfish, as you know, have been there for a little while. Glassfish being the reference implementation, Wildfly being sort of the upstream research and development or community effort from Red Hat. Beyond that, we've also had some more recent additions. So hopefully some of you are already aware of this. But WebLogic was just certified, fully certified on Java EE7 in the Java 1 OW timeframe. I'm actually just coming from there. I lead the server-side track at Java 1. So that is already available. So WebLogic customers have had partial Java EE7 support for a year now. Now they have a fully certified platform in terms of WebLogic, that supports all of the Java EE7 APIs. Also, more recently, we've had a fully certified Java EE7 release of WebSphere Liberty Profile. So again, they beat us this time by a few months. So again, Liberty is a very nice, clean implementation of WebSphere. It's getting a lot of traction in the industry, certainly. That, again, is fully certified against Java EE7. So there's full support of Java EE7 from IBM. They're also going to certify WebSphere Classic, sort of the older implementation of WebSphere, on Java 7 as well. They, I believe, just released a beta with majority of the Java 7 APIs. So chances are by the end of this year, even the older WebSphere Classic version will also be fully Java 7 certified. A lot of people don't realize this, but we also have some niche players that are regional players out there. So Hitachi being in Japan, Tmaxsoft being in Korea. These are also full Java 7 platforms, and we have others coming right down the line as well. At Java 1, Red Hat announced their plans for releasing betas and going final with Java 7 with JBoss EAP, their commercial offering, and by the end of this year. So that also will be available very soon. Some of you may be aware of Apache Tom EE. It's a very interesting implementation in that it takes a plain Tomcat container and turns it into a Java E7 implementation, web profile implementation. Again, they are also working on Tom EE 7.0, which is targeted for Java E7 certification. There's a few others in the pipeline as well. So again, we have a few other Japanese licensees, Fujitsu and NEC. As well as SAP also traditionally comes around to having their compatible Java 7 implementations as well. So probably that is somewhere sometime next year. Okay, so without further ado, let's dive into the application. This is the first step, to understand what the application is, what is it that it does, before we move into the code and sort of seeing how the code works. So this is an application that's actually a project of mine. I sort of run this project in my spare time. It's my pet project at Oracle. I'll describe to you what the project is really all about. The subtitle, I think, describes it well. It says Applied Domain-Driven Blueprints for Java EE. So some of you may be familiar with this old application called the Pet Store or the J2E Blueprints. Basically, what I'm trying to accomplish with this application is to create a modernized version of this. Except, of course, instead of using J2EE, we're using Java EE7 and hopefully moving forward, Java EE8. And the other big difference is we're not actually sort of creating our own patterns. We're taking established patterns that are out there in the industry and applying it in the Java EE context. The biggest one being domain-driven design. I happen to be a proponent of domain-driven design. So that's the principal goal of the application. It's to show you how to architect good solid applications using Java EE platform, using mainstream architectural design techniques. But the nice thing about it is it's a relatively non-trivial application because you can't show good architectural principles in a trivial application. And it also happens to include a lot of Java EE features, and in fact, a lot of Java E7 features. So much so that I can actually sort of misuse, if you will, the application to do this tutorial. So how can you get your hands on the application? It's very, very simple. The application is available at cargotracker.java.net. In fact, here's a bit of a challenge, if you will, if you're up for it. By default, this tutorial is a lecture, and so I'll be lecturing for the next 162 minutes. That's what I have left now. But if you wanted to, you can actually turn this into a hands-on lab of sorts. Okay, and people have done this successfully. They've actually run the application on their own laptop while still following the workshop. You can do so. How do you do so? Well, you can do so by going to this URL. Okay, cargotracker.java.net hashtag or hash get started. Okay, it'll take you to a section of the website that you can actually go ahead and get the application set up in your own environment. You can use either NetBeans or Eclipse. It's your choice. All right. But before we move out of here, I also want to point out the website itself. Okay, so the website has some useful information in it, the overview of the project itself, some goals, some background context, some primers on things like domain-driven design and what it hopes to accomplish. But most importantly, there's a set of resources down below. Okay, so you can browse the source code or download the source code from Subversion. You can contribute to the source code as well. You're more than welcome to do so. We're always looking for contributors. You can also use the issue tracker. If you run into any issues, you can report that back to us. And you can also, there's a mailing list. You can participate in the mailing list. You can discuss specific issues, either domain-driven design or Java E7, or how these features are used in the application. So all of those are resources that are for you. In fact, I would say this is probably the most important resource that you will get out of this tutorial. Okay, the one that you can take home and work on your own. The other thing that I will point out while we're doing this, while we're here about talking about resources, take a look at my slide deck for a second. Okay, so you will notice that this slide deck is actually completely annotated. Every single slide on the slide deck has speaker notes to it. Okay, this is on purpose because this is also a resource for you to refer back. Okay. So how do you get your hands on the slide deck? Well, it's quite simple. I just uploaded it, and I've tweeted it to the Devoxx hashtag. There's the tweet right there. Okay, so I'll let you take a look at that in a second. If you go and follow that, it'll take you to a Google Drive file. It's actually the source PowerPoint, so that you can take a look at the speaker notes. Before I move forward, I'll let you take a look at the URL for that. In fact, you know, getting these Twitter URLs are usually a fool's errand. Yes, it's a fool's errand. You can simply look at my Twitter stream and pick that up from there. Okay? All right, moving forward. What is the application about? So I have the application up and running in NetBeans and Glassfish. It's a Java E7 application. Although it's running on Glassfish, in theory, you could run it on Wildfly. In fact, somebody did attempt to do that, and they did succeed. You could run it on any Java E7 application server, not just Glassfish and Wildfly. Also, it's simply a Maven project. Okay, so you can run it on Eclipse as well. In fact, we have instructions on how to run it on Eclipse. You can run it on IntelliJ if you so wish as well. I happen to be using NetBeans and Glassfish. This is the application up and running. Okay, so as you can see, the purpose of the application is sort of implied by its name. Okay, and of course the imagery that's on this page as well. So what does it do? It basically tracks cargo going across the globe. All right, so you're a shipping company, and what you do is you take in cargo and you move cargo from one place to the other. You manage all of these things and also give your consumers some visibility on what's going on in their cargo. There's a few distinct interfaces to this application. The first is a public tracking interface. I'll show you that real quick. Okay. And what you can do through this public tracking interface is once you've registered your cargo with the provider, you're given a tracking ID. So you can now track what the status of your cargo is, similar to what you have for FedEx or USPS. I'm not sure what you guys have in Europe. I imagine something fairly similar. So we have an autocomplete here. So I'll just do a search on ABC123 and hit track. And I get a bit of information about what is happening with my cargo. The cargo is currently in New York. Its estimated time of arrival in Helsinki, you know, what happened with this cargo, okay, the events that occurred, and a map sort of showing, you know, where the major events that occurred on this bit of cargo is. Okay, so that's one interface. The other interface is a bit more involved, and okay, I think I need to reduce my... So you might have noticed this is a responsive UI, right? So when I reduce the, or rather increase the available size, the amount of data also increased. Okay, that aside. This is basically the major control panel for the bit of cargo. This is intended for the folks administering the cargo. Okay, so the cargo company. In this over here, you have a dashboard. It's telling you, okay, these are all of the registered bits of cargo you have. This is what their current status is. Some cargo is routed, some is not routed yet, okay, and some is claimed, and so on and so forth. You can go ahead and book cargo, which we'll do in just a second, actually. There's also a live map visual version of the control panel that you saw. Over here, basically, the dots represent bits of cargo where they are in the world at the moment. If you hover over them, it'll tell you a bit more information about that bit of cargo. So the tracking ID, what is its status? Let's pick another one that has been routed. This one happens to be misrouted, okay, and it's claimed and so on. Okay, so you get a bit of information about the cargo through this map. This map is actually more interesting than simply a visual representation. We'll see that in just a second as well. You can also book cargo. So let's go ahead and do that. Okay, so I'll go and say book. I'll say my cargo is going from New York to Tokyo. And I'll pick a date that's reasonable. So I'll say January 22nd. Okay, that gives me about 74 days. That's good enough. And I go ahead and book this cargo. So if I go back in here, you'll see that I have a new entry going from New York to Tokyo. Okay, and that is, I've been given a tracking ID. That's a generated tracking ID. We can go and actually look at this tracking ID. Whoops, let me copy that over. In the public tracking interface, enter it, say track. Okay, it's not received yet. We don't know what the estimated arrival time in Tokyo is because we haven't routed it yet. Okay, so we'll go ahead and go back to the dashboard. And we'll now route this cargo. Okay, that's what this little globe icon is. Okay, so we registered the bit of cargo. Now, as an administrator, I need to figure out, okay, the customer wants to go from here to here in this deadline. How do I actually do that? So I'll go ahead and pick a routing option. And what happens here is that this is a sort of a traveling salesman problem. Okay, so I have several voyages in my hand and some specific metrics of how I can get from point A to point B in a specific deadline. So I have several options of how to go about routing this cargo. It's similar to perhaps an airline reservation system that some of you, I'm sure, have used. So I'll pick one. I'll just randomly pick route candidate 2. All right, going back to the dashboard. You'll notice that it has now moved into status routed, okay, so on and so forth. There's also another interface, and that is a mobile interface, okay? So what this mobile interface allows me to do is enter information about cargo. So this interface is intended for people at the various ports, okay? So they have to enter information about what is going on with the cargo. All right. I won't tell you too much about it now. Well, let's revisit this later. But basically, what's happening here is that, for example, when I receive this bit of cargo, the way I get this information back into the system is somebody opens up this mobile device and enters in the tracking ID, enters in the fact that they've received this cargo at a certain port. And that is what will update the system status on behind the scenes. And we'll see that in a second. Let me refresh this now. Okay. Hold on just a second. I think we have a small bug with this interface that I will need to take a look at later. I was suspecting this might happen. Okay, good. All right, that's good enough for now. Let's move back into the slide deck for a second. All right, so that's a good enough introduction into the application. We'll revisit parts of the application later and actually dig into how the application is doing some of the things that I described. But let's start our tour of Java E7 in terms of the API changes that are in it. Okay, again, the basic format, remember, is that I'll talk through some of these API changes. I'll show you some of the API changes in the code itself. In case of JMS 2.2, it's actually quite good. I can show you a majority of the changes that were introduced in JMS 2.1. So now is a time for me to explain the color coding that I'm using in these slides. So the text that is in black, okay, is actually things that I will talk about. And actually, I will demonstrate. I will show you how this code actually looks like in the application and explain the why and the how. Okay, the part that is in gray, I don't have in the application, principally because I don't have a use case for it. Those things I will talk about, but I won't actually show you in the code. All right, fair enough. Moving forward. So what exactly is in JMS 2.0? The big change in JMS 2.0, as I said, is really about API modernization. The JMS 2.0 API has not been updated for quite a long time. The last time it was updated was in the J2EE 1.4 era. So as you can imagine, that's a huge time lag for this successful, still widely used API. So the biggest thing we needed to do is modernize this API, okay, make this API worthy of 2015 and forward. So what did we do? We basically took a lot of techniques that we already know about, so things like dependency injection, fluent APIs or builder-style patterns, convention over configuration, unchecked exceptions versus checked exceptions, and basically created an API that looks and feels a lot more modern and is a lot more productive as opposed to the old JMS 1.1 API. I think once I show you the JMS 2.2 API, you'll notice the radical change. You know that if you've ever done anything in JMS 1.1, this API will look almost unrecognizable in how different and how productive it actually is. Now, beyond simply API modernization, we did actually look at adding features to JMS 2.0. And in fact, this entire effort of JMS 2.0 was relatively democratic. We actually polled the entire expert group and asked them, hey, put on the table, what is it the things that you would like to work on in JMS 2.0? And by and large, it's not surprising that the biggest wish list item was API modernization, in fact. Okay. However, beyond API modernization, there was a small number of new feature requests, not a lot, and hence we actually wound up just adding just a few of those new features. What are these? Two in particular. One is a delivery delay feature, and the other is something called async send. What is delivery delay? So in JMS applications, there's a common pattern out there that people use JMS as an event triggering mechanism. Okay, so they want to do something in their system, and they say, hey, let me fire off a JMS message, and I'll pick this JMS message later on to do something useful with it, to trigger some event in my system. The general pattern is, they send a message to a queue, and then they have a scheduled job that's running on a specific time frame that picks up the existence of this message and uses it to trigger a workflow. So we wanted to make this a bit easier, and it's actually relatively simple to make this easier, and that is simply allowing you to trigger a JMS message when you do a send. Okay, so using this feature, what you really do is you say, hey, I want to send this message. This message is going to do something to my system, but don't send it right at this moment. Okay, really what I need is for you to send this message at a specific time delay. Let's say at the end of the day or a specific time frame that is significant for the system. Okay, the other one is asynchronous sends, and I actually have a talk on sort of this theme of asynchrony. It's called reactive Java EE, but basically this particular feature goes towards that concept of reactivity. By default today, when you do a message send, you actually block on that send. Okay, you actually do not return your thread. You don't get control over your thread back until you get an acknowledgement from the message provider that yes, your message has actually been sent. Now, the latency for this is not very significant. It's usually in the order of a few milliseconds for a given message. The problem comes in when you're talking about large volumes of messages. So let's assume for a second that either one, your application is heavily message dependent and you send a lot of these messages, okay, and you're hence, in net you're doing quite a bit of thread weights, okay, to get the acknowledgement from the message-oriented provider, or perhaps you send messages in bulk. So maybe you might have a use case where you're sending 10,000 messages, in one go. So the latency will become important then. Okay, so what this feature allows you to do is basically do the actual act of send in an async fashion. All right, so you say, please send this message, but the actual send does not occur in the current thread. Okay, you get a return back immediately after you do the send request, and the actual send actually occurs on a separate thread, and that improves your latency. The other thing that we were able to do in JMS 2.0 is actually make the JMS API a bit more usable inside of Java EE applications. This also bears a bit of explanation. So in the JMS 1.1 timeframe, JMS was sort of an interesting API. In fact, it continues to be interesting in this way as well. So JMS has a life within the Java EE applications, and actually a large majority of JMS usage happens in Java EE runtimes. But if you look at the JMS 1.1 API, it actually says very little about how it is used in a Java EE environment. The reason for this is the JMS API is actually usable outside of Java EE and inside of Java EE. So there is actually JMS providers that certify JMS just on a Java SE platform. Now, of course, in 2015, we've learned lessons from things like Ruby on Rails that if you include an API in the platform, you should also be focusing on how that API is usable and integrates well into this platform. So we took advantage of some of these things in Java EE 7, in JMS 2.2 as well. We made sure that the JMS API is very, very usable in its primary delivery mechanisms, so things like message-driven beans, as well as things like being able to define JMS resources within the application. We'll see that in just a second when we look at the code. Okay. So here's a pop quiz for you, and it's a good question. It's a good mental exercise. Where do the application actually uses JMS as a fundamental way of improving scalability within the application? I want you to think about this application for a second, and can anyone guess where we're using JMS? Where are we using JMS? Another clue is ensuring scalability. So where might we have a scalability problem in this application in terms of data entry that can be solvable via JMS? Anyone want to venture a guess? No? Yes? The public interface is generally not going to be a scalability problem. It's just a CRUD API. Somebody logs in and does a search. We do a simple database lookup and show some results. No, that's not it. And the volume of that is not going to be very high, really. Okay. Any other guesses? Precisely, yes. Okay, so let's think about this problem for a second. So, in a realistic application, you'll have thousands of these bits of cargo, right? And all over the world. And you'll have thousands of people actively working on updating the status of these bits of cargo in various ports using these mobile devices. Okay? So that's a potential scalability problem because of the potential volume of data that you're handling, potential volume of concurrent data that you're handling, and the amount of processing that you actually need to do to update the status of a cargo. Updating the status of a cargo is a non-trivial operation. There's actually a significant amount of work that needs to happen to properly update the status and the data behind a bit of cargo. So if we try to do this in a synchronous fashion, The problem is we may overwhelm the system with the amount of data that we are receiving. Okay, so the way to solve this problem is applying JMS and using essentially the concepts of reactive programming. So what we are actually doing here is that whenever we receive a cargo update from here, by the way, this is actually not a part of the application per se. This is just nothing on the server side. It's actually just a HTML5 page. What it does is that it produces a REST request, but at the end of the day, that REST request translates into a JMS message. Okay, so what we do is we have a bunch of inbound JMS messages, each corresponding to events that happen to the cargo. Okay, and then what we have is actually a single message-driven bean instance that listens on all of these messages and processes them in a scalable fashion. Okay, so it doesn't, if you have suddenly a sudden burst of 10,000 requests to update cargo, well, all of those, we don't spawn 10,000 threads. Okay, all we really do is we spawn a limited amount of threads, perhaps 10 at a time or 100 at a time, processing each of these messages behind the scenes. All right, now let's take a look at the code. So ultimately what happens is if you look at this application, and I'll show you a bit of navigate a bit of the application for you right now. The application uses domain-driven design. So I won't go in too much into how the packaging structure here looks like, but it's relatively navigable, okay, if you spend a little bit of time looking at the application. The code that we're actually interested in is under the infrastructure messaging JMS package. In the end, there is actually a JMS application events object, okay, that sends out the message. So here we go. Let's take a look at this method. This is a method that actually gets invoked when I make from my mobile device when I actually enter a cargo handling registration attempt. So this is my domain object representing that event. Okay, it's called handling event registration attempt. And again, I don't actually do anything. I don't do any real processing. I don't actually save anything in the database. In the end, what I really do is this one line of code. Okay, and if you haven't seen JMS 2.0, this one line of code should look a bit interesting. So let's move this here. Okay, so you can kind of sort of see what's going on. All right. So all I do as soon as I receive an event update is actually just to push it into a queue. Right. And this is the code that does that. It's just one line. Let me show you that for real. Okay. Here's the cargo handling registration attempt code, and this is it. This is all you need to do. Is this one line of code to send a message. In JMS 1.1, in order to accomplish this, it would be more like 15 or 20 lines of code. All right. So you'd have an open and a close. You'd have a bunch of intermediate objects that you'd need to create, like connection, session, and message producer and message. Okay. And you'd have to do exception handling as well, because in JMS 1.1, everything is a checked exception. Right. And I'm applying doing all of those things and more. I'm not just sending a message to a queue. I'm also setting some quality of service parameters. Right? So I'm setting the message priority to be low, and I'm doing some optimization here as well. These optimizations probably will not look familiar to you if you're a JMS 1.1 user. These are a few other features that were added in JMS 1.1. Specifically, I have no use for a generated message ID or a timestamp. So I can disable both of those and have the underlying message-oriented middleware not produce those. Also notice there is no creation of a JMS message here at all. Okay, I'm simply taking my POJO, okay, and sending it directly to a queue. All right, and there is just one API that you need to learn, and that is this thing called JMS context. That's it. If you know this API, you basically know JMS in JMS 2.0. It's boiled down to something that simple. How do you get a handle to the JMS context? Well, it's simply this. Okay, it's inject JMS context. That's it. Okay, there is no connection factory that you need to worry about. No session, no message producer, no nothing. How do you do this? It is because we've actually designed it such that you never need to deal with connection factories anymore. You have a platform default connection factory that is shipped by default with you. Okay, in JMS 1.1, the first thing you need to do with anything with JMS is actually create a connection factory. Then you no longer need to do that. It becomes just a one-liner. Right? You can't get significantly more complex than this. And what you've also may have noticed is that this API, like many of the other Java EE APIs these days, uses the builder pattern. And that gives you a whole bunch of capabilities. It allows you to do convention over configuration. It allows you to do sort of a very fluent API, flexible fluent API style. So all of the crazy things that you can actually do with JMS 1.1, you can continue to do with this API in a far more compact fashion. Now, we also should see one more part of this, and that is the queue that we're actually using to register this event. So the queue that we are using is called, sorry, this is not it. Yes, it's a handling event queue. Okay, so handling event queue is injected into this POJO using the add resource annotation. The JNDI lookup name is registered to be Java Global JMS Handling Event Registration Attempt queue. All right, so the question is, in JMS, prior to Java E7, how would you actually go about creating this queue? What do you expect to do? How will this queue come about in Java E6 applications? JNDI lookup, but how would this queue actually come to exist in the first place?
Configuration inside the server.
Correct, yeah. So there would be some a vendor-specific way of creating this queue. Right, so you would perhaps go into the admin console and use a wizard to create this queue, or use some command line utilities, or use some vendor-specific XML to actually physically create this queue. Well, in Java E7, you can do all of that, and in some cases you would want to do that. So there are still legitimate cases where you want the administrator to be creating these resources and not an application developer. But lo and behold, this is actually not what is happening in this application. I'll show you where this queue is actually being created and how. All right? So this is a web XML for my application. And if you look a little bit farther down in this web XML, you'll see this funny looking elements. All right? This is actually how these queues, actually there's 6 different queues I use within this application. This is how these queues are actually created. Okay, it's simply a standard element that you can use either in WebXML or application.xml or ejbjar.xml, some kind of XML deployment descriptor. And it's simply called JMS destination. It's got these few elements to it, and this is how you create it. So what is actually happening here is that these queues are actually being created or verified during application deployment, and it is specified by the application itself and the application developer themselves. All right? And of course, there's annotation versions of this as well. I happen to be using XML. I think this is a good use case for XML. I've explained in the comment of the web XML why I think actually this is a good use case for XML instead of doing this in annotations. But the annotation version is also very simple. It's simply called @JMS resource definition. That's it. Sorry, JMS destination definition. Pardon me. Finally, let's take a look at the receiving side of this MDB. So the receiving side is also in the JMS message package. It's called Handling Event Registration Attempt Consumer. Okay, so you'll notice the naming convention that I'm using here. It makes it relatively easy to find out what it is that you're looking for. If you haven't seen MDBs before, it's really quite simple. Just the on-message callback is just a POJO, and on the on-message callback, I'm unwrapping the actual registration attempt that I have here. Okay, and here is where I actually do something real, right? So I actually I call a backend service here, okay, to register the event handling event, and this is where the update change for actually propagating the status update for cargo happens. Okay, not before this. Now, if you look back up into the top of this of Pojo, this is simply one annotation called message-driven bean, and that has completely standard properties. Okay, so if you, for those of you who have worked with message-driven beans in Java E6, these activation properties, things like destination type, destination lookup, these were actually all non-standard. Okay, which means they varied from one application server to another application server. These names would be different in JBoss, from Glassfish and WebLogic and the like. So now we've actually standardized all of these things. So these all have standard names. So the standard name for what queue you listen to is simply destination lookup, and it's simply, you give it simply the JNDI name. Destination type, okay, is either queue or topic. Similarly, pretty much all of the things that you would use in a message-driven bean now all have standard names. Okay, so connection factory, selectors, durable subscription names, everything is standard. In most cases, you shouldn't need to use vendor proprietary activation configuration name properties anymore. There are some cases where you might, but it's an unlikely case. Okay, in most cases, you should be good to go. All right. Any questions on any of this before we move on from JMS 2.0? No? We're okay? All right, moving forward. Java API for WebSocket. Okay, so quick a show of hands. How many of you actually know what WebSocket is? Okay, most of the room, but there's still some folks in the room that don't. So for your benefits, so that you're not lost, I will describe to you exactly what WebSocket is. WebSocket is actually something that was standardized as part of HTML5. It's an HTML5 body of standard work, a bit of work in the HTML5 body of standards. What does it do? It actually gives you an alternative to vanilla HTTP. Vanilla HTTP is very simple. It's completely stateless, right? So the normal lifecycle for a vanilla HTTP request is simply, here's a browser, here's a server. The browser makes a request for a page or a resource on the server. The server resolves this request. Okay, figures out how this request is to be produced, produces this response. Okay, and the connection is closed immediately. Okay, and there is no state that is shared across requests. It's a completely stateless protocol. This, of course, we know works quite well, and it works quite well for most web applications. Works quite well for REST. If we want to do some kind of state management, we can use things like cookies to do that and the like. However, there's a certain class of applications for which this actually doesn't work. Okay, it winds up being either inefficient or not possible at all. So this class of applications is a classical example of this is chat or online multiplayer games. So what is the pattern of communication here? First of all, the frequency of communication is quite a bit higher than just loading a web page. Okay, there's a lot of chatter going on. Okay, in these types of applications, and the pattern of communication is really, the client makes a request, okay, to the server, which is fine. However, that's possible in vanilla HTTP. However, in these sorts of applications, there's also communication from the other end. And again, a classical example is chat. So you connect up to a chat client and connect chat server as a chat client. In addition to you sending message to the chat server, you also asynchronously receive messages from the server. Okay, if somebody else sends a chat message, that chat message is sent to you. Same thing with all online multiplayer games. So you are connected to a centralized game server. You do stuff to the game, but because there's other players doing stuff to the game as well, you get notifications, asynchronous notifications from the server down to your client. So it almost reverses the communication, path of communication between the client and the server. Those cases are really not handled very well with HTTP. All right, and that is where WebSocket comes in. So what is WebSocket at its heart? The nice thing is, the thing that we're after is actually accomplishable in a protocol that we're already using. Because behind the scenes, HTTP uses nothing much more than TCP. And TCP happens to be a connection, a stateful connection-oriented protocol. In fact, although HTTP looks stateless to us, behind the scenes, the TCP protocol actually does bidirectional communication. So it does things like keep alives and the like. So what WebSocket does is that it uses HTTP as a communication backbone. So the initial connection between the client and the server is established using HTTP. Using HTTP. But what happens after that is once the initial connection is established, the client and the server both agree that they're going to talk one layer below. So they're going to talk very much through an API that looks like a raw TCP. All right? And that enables us in the end to have full duplex bidirectional communication. We'll see that in a second when I show you the actual demo, and you'll see how different it is from normal HTTP connections. Now, of course, in Java E7, just because you're doing things something like that looks like TCP, we don't want you to be doing sort of the old style TCP programming. How does that look like? Okay, open up a server endpoint, okay, register a listener and handle each of these listeners on a separate thread, so on and so forth. So in Java E7, what you have instead is a pretty high-level API, looks very much like actually JAX-RS, or any other modern Java API like Servlet. POJOs, annotations, a very high-level API, just some simple callback annotations, and that's it. Okay. Again, I'll show you how that looks like in a second. Majority of the time, as server-side Java developers, you'll be developing server-side endpoints. So there is definitely support for that. There's a server-side API for Java API for WebSocket. However, there's also a client-side API. And you might ask, well, why is this useful? There are several use cases why that's useful. One is if you're doing machine-to-machine communication. Okay, one Java server talking to another Java server, and they're simply using WebSocket as a communication protocol. So in that case, you need the server endpoint, and you need a Java client as well. Another common use case is testing. So let's say you've developed this nice WebSocket endpoint. Well, you need to test it somehow. You need to do integration testing. That's usually going to happen in a Java API like JUnit or TestNG or what have you. Again, you need a Java-based client to do that. Again, also, you may be lucky enough so that your client is actually written in Java. Perhaps you're writing a Swing application or a JavaFX application or what have you. Right. So there is a client and a server-side API. I won't show you the client-side API. Largely, I'll be showing you the server-side API in the application, but both exist. There's also a declarative and a programmatic API. And the declarative API, again, I mentioned simply POJOs and annotations. However, there's also a lower-level API that looks more like Servlet 2x or EJB 2x style API. When do you need this? Probably a vast majority of enterprise developers don't need it. But there's a fundamental reason when you actually require a programmatic API, and that is when you don't know at deployment time how your application wiring is going to look like. Okay, so this is, for example, a case for anyone building upon this Java API for WebSocket, creating frameworks on top of it. So they wouldn't know, what endpoints they need to deploy, how the URLs are going to look like, what the timeout is going to look like. Perhaps they are reading that information using reflection, looking at your API, or looking at some other deployment descriptor that they may have. So those folks actually do need to programmatically create server endpoints and the like. Again, we won't. I won't show you that. I'll just simply show you the simpler declarative API. But know that both varieties exist for the Java API for WebSocket. In addition to that, it also has other pluggability and extensibility points. So you can actually talk directly at the WebSocket runtime level and give it specific behavioral instructions. And again, that's helpful for folks building upon the Java API for WebSocket. Again, I won't cover that, but that does exist. All right. So to show you how the Java API for WebSocket is taking, what its use here is, let's go back to the live map for a second. All right, so and let's go back to the thing that we had created before. So this is that's our tracking ID. Okay, notice that it's routed. It has not been received yet. So let's go ahead and say that we're receiving this bit of cargo, and we're receiving it in New York. All right, hopefully this all goes well. Sometimes I do wind up with errors when I try to do this. So we'll pick a tracking ID. This is our new tracking ID. All right, we'll pick a port. Our port is going to be New York. The event is going to be of type receive. And oh dear, I have some error going on. Okay, quite possibly I need to refresh that page. So let me just let me re-enter this URL. .xhtml, hit go. Okay, it's a bit better. Let's see what happens now. Tracking ID is that. Okay, port is New York. Event is receive. Okay, much better. All right, so, all right, I'm going to pick hit next. Pick a date for my event. I'll pick today, which is November 9th. All right. Now, before I hit submit, I want you to keep an eye on what happens when I hit submit on this page here, all right, on the live map. So I'm hitting submit. All right. Notice that the color of that dot has now changed. Right, and and that happened asynchronously. Okay, so I'm just some random person on a port. Okay, entering a bit of data. Okay, in this case, saying that a cargo was received, and this other person is just again has nothing to do with me. He's just monitoring the status of the cargo on this live map, and as a result of what I did, you know, this page was auto-refreshed. All right, this is actually WebSocket in action. Hopefully, this is not something you see every day, right? So this is essentially WebSocket in action. How did this occur? So the way this occurred is, first of all, when I am registering a bit of cargo, I am actually triggering an event. You'll see that in just a second, actually, how I go about triggering that event. But when I'm actually done updating my cargo, and I say, hey, the cargo status is now completely up to date, which actually goes through several steps before it can get to that, I generate an event on the CDI event bus to say, this bit of cargo has been updated. Here's the most up-to-date cargo information. That event actually triggers a server-side update to this page. All right. Now, looking at the other side, what happens is this is an HTML5 page. All right. This HTML5 page actually is making a WebSocket connection to an endpoint on the server. It's saying, hey, I'm somebody who's interested in cargo events. I'm creating a WebSocket connection for you. As soon as you change something with cargo, please update me. All right, and then there is a WebSocket. My CDI event bus actually winds up updating this event chain through WebSocket. All right, so let's take a look at the code and to see how that is actually happening. First, I'll show you the actual CDI event actually. So that is inside. So if you look at this bit of code, there's actually a package called CDI event. It's something called cargo inspected. Cargo inspected is actually just a qualifier. I'll search for the usages of that qualifier. Okay, and notice that it's actually being used on 2 separate places. Okay, so it's being used in the, let me minimize this a bit more, maximize this a bit more. Default cargo inspection service. Okay, so this is the service that actually is responsible for updating the cargo. We'll take a look at that in a second and see where this event qualifier actually is used there. The other place it's used is, notice, is on something called real-time cargo tracking service. And this is actually the WebSocket endpoint, okay, that my HTML5 page is listening at. On that page, there's actually a callback called on cargo inspected. Okay, so that is what my receiving end of my CDI, on my CDI event bus. So first, let's take a look at line 28. All right, cargo inspected. I'm injecting a cargo event. Okay, this is a CDI event. My payload is cargo. And where I'm actually firing this is here. All right, notice that I'm doing a whole bunch of things to update cargo status. Okay, so here, you can see this right here. Cargo.derive delivery progress from handling history. Okay, this is where the cargo status is actually being updated. I'm storing that cargo information in my database called cargo via cargo repository.store. And when I'm done all of that, okay, finally I am actually triggering this event, cargo inspected.fire. I'm firing the event and giving it the cargo as my payload. This winds up in the CDI event bus. Now, let me go find usages. And now let's take a look at the real-time cargo inspection service, cargo tracking service. So let's take a look at this Fojo. Let's revisit that at observes annotation in a second, but not quite yet. Okay, but keep that in mind. I now have an event on the CDI event bus that I'm going to react to. This is my WebSocket endpoint. This is how you create a WebSocket endpoint. It's simply a POJO. Okay, this is a POJO. It happens to be a singleton. I want it to be a singleton because I want it to be thread safe. This object to be thread safe. The way you simply publish a WebSocket endpoint is simply by saying server endpoint and giving it a URL. Okay, now anybody can actually connect up to this WebSocket endpoint, and that's all you need to do. No configuration of the system, no nothing. It's just that. Okay, you'll also notice there's a couple of funky methods here called on open and on close, and you can name these whatever you want, whatever makes sense to you. The important part is those two callback annotations that you see there. On open and on close. What do those stand for? On open essentially is invoked whenever a new connection comes into the WebSocket endpoint. Somebody new is connecting to me. Similarly, on close is invoked when a connection is closed. How does this happen? Well, there's a couple of different ways. Somebody could explicitly say, WebSocket.close on the browser, or they may simply leave that page or close that browser instance. When they do that, it'll wind up being a WebSocket close. On WebSocket open and close, I actually am doing nothing much more than keeping track of who is currently connected to me. All right, so I have a collection that I'm adding to, okay, whenever a new connection is created, and a collection that I'm removing from, okay, whenever I'm losing a connection. If you see, the sessions object is really nothing much more than a set, okay, a hash set that I create. Now, what happens is whenever this, at any given instance, this WebSocket connection now has a list of open clients, right? It knows who are the currently live clients. So now what happens is it also can receive events from the CDI event bus, and that's what's happening here. Notice at observes cargo inspected cargo annotation. All right. So I am receiving events from the CDI event bus whenever a cargo is being changed in the system. And what I wind up doing in the end, okay, is actually iterating over each of my active sessions. That's where the for loop is coming from, and sending them a copy of the cargo status. And we'll see in a second how JSON value is produced when we talk about the Java API for JSON processing in a second. But basically, I'm iterating through each of my active sessions and sending them an update. Okay, this bit of cargo is updated. Please update yourself. All right.
Reza,
Yes.
couldn't the management of these sessions be put somewhere beneath the API level? You are talking about simplifying things, developer productivity. To me, this looks like I'm getting the burden of maintaining this hash set and iterating with the for loop. Could have been in the API yet.
Yes, so there's a couple of different ways where that actually is done. So one is that there's one callback that I haven't showed you in this code called onMessage. And that onMessage callback is, okay, you open and close a connection, that's fine. But when a client endpoint actually sends you a WebSocket message, that WebSocket message triggers an onMessage callback. And in the onMessage callback, you can simply get as a parameter to that method invocation, you can get a list of the current sessions. Right? So you don't, in that case, you don't actually have to maintain the list of active sessions. The problem in this case is we don't have that use case in this case. Right? We're not waiting for a message from the client for us to do anything. We're simply sending events back. So in this case, I have no choice but to maintain the list of active connections myself. Because the trigger is something different. The trigger in this case is a CDI, not a JMS message. The other thing is, if your API is as simple as when you receive a message, send a client a request response back to that message, you also actually don't need to worry about maintaining the active list of sessions, because what happens is if you have a return type on your onMessage callback, that return type translates into a response back to the client that sent you the request. So yes, there's some bit of syntactic sugar available to you so that you don't have to maintain a list of active sessions. In this case, I don't really have a choice because I'm doing something a bit different than what you perhaps normally would do using WebSocket. Okay, any other questions on WebSocket? No? All right, moving forward. So let's now move into the bit of code that I didn't show you, and that is the Java API for JSON processing. So what is this all about? If you looked 5 years before, or perhaps even certainly 10 years before, and you ask somebody, you're going to do communication over the web, what should be your data serialization format? The answer you would get is XML, right? The problem is that XML is good and bad for that purpose. If you look in the roots of XML, it was actually never intended as a data interchange format. It was essentially created as a way of describing data in a human-readable format. Right? And largely when you're talking about data interchange, you're not talking about humans, you're talking about machine-to-machine communication. So there's no question of somebody really being able to read that data anyway. Okay? The sweet spot for XML, in my mind, is actually configuration. And it's arguable how good it is to do even that, but even things like markup, that's a good use case for it. Because you need that thing to be human-readable. Right? You need that to be relatively self-describing. There are some good elements of XML, why it's a good data interchange format. The principal one being that it is ASCII-based. Okay? And because it's ASCII-based, that means it's cross-platform. Right? You can process it in any language or any runtime. The downsides of XML, on the other hand, is because it's self-describing, it tends to be far more verbose than it needs to be. And it is also very, very type safe. XML has a lot of complex types. In the end, that's a nice thing, okay? From a consistency and reliability standpoint, it's not such a good thing when you're having to deal with writing parsers, okay? Because you have to pay either a memory cost or a CPU cost. And also an I/O cost when you're talking about increased bandwidth in XML. So for that reason, I think we're very fortunate to have an alternative that actually has all the strengths of XML and almost none of the weaknesses, and that is JSON. Okay, JSON, of course, hopefully most of you know, is really just a native data serialization format for JavaScript. But it happens to have some very good characteristics that make it good as a data interchange format, even if neither your client, or your server is written in JavaScript. So, what are the good things about JSON? The first thing is that it is also ASCII-based, just like XML, which means that it is cross-platform. However, JSON is also relatively compact and reasonably readable. Okay, so it's not unreadable. So it's certainly much more readable than binary. You can still open up a JSON document and reasonably understand what this document is about. You get a bit of readability. But also, it's far more compact in nature. Okay, so it's not designed to be as self-describing as XML is, which is very important in terms of saving I/O. Okay, and in terms of saving bandwidth. And its type system is very simple. Okay, really there's 3 different types: arrays, int, string, and perhaps null, and might be a null, or numeric might be another type, but that's it. There's no notion of complex types or anything else like that, which means writing parsers for it is significantly simpler. In fact, you can probably handwrite a JSON parser if you so wish. Now, so the question is, if JSON is so important, and it is becoming important, if you look in the industry today, pretty much anyone that's doing anything with REST, anyone that's writing any rich UIs, they're writing it in JSON. So for any feature-complete platform, which Java EE aims to be, it then doesn't really make sense for us to tell you, hey, JSON is great, we know it's great. Oh, by the way, if you want to do anything with the REST or WebSocket in JSON, well, you better go find a third-party library to do the parsing for you. So just like we did for XML, we want to reach a state in the Java EE platform where JSON becomes yet another data serialization format supported by the platform, just like Java serialization. So the first step to doing that is a Java API for JSON processing. We can, this is actually the first step to the natural next step, which is JSON binding API, which I'll talk about in just a second. So this API basically allows you to do what you were able to do in JAX-P, the Java API for XML processing. To give you sort of a mental jog, this is things like DOM API, SAX API, Stacks API, okay, low-level API to do stuff. And this is basically the JSON version of doing that. And we'll see code examples of how this API looks like in a second. Just like JAX-P, this actually does come with 2 different flavors. Okay, an object model API similar to DOM, and a streaming API similar to Stacks. And it has the trade-offs of that we know about. Okay, in terms of memory versus CPU. So it's a question of which one do you use. Actually, I really do think when you're going to be using the Java API for JSON processing, a majority of the time you'll wind up with the streaming API. With the streaming API. And in fact, my example that I'll show you is a streaming API, not the object model API. Ultimately, though, where do we want to go? In the end, as I said, we want JSON serialization to be as natural to you as Java serialization is. in order to serialize a Java object, you don't have to do very much. You don't write low-level APIs to say, please transform this property into this binary field and the like. It just happens for you in a declarative fashion. So in the end, we do want that type of declarative support for JSON as well. We certainly have it for XML. We have the Java API for JSON binding. Again, you do very little work to do that. So that work is going on right now. It's called the Java API for JSON binding. It will be included in Java EE 8, not in Java EE 7. Of course, now in all reality, we already do support JSON binding of sorts in application servers like Glassfish or Wildfly or JBoss. Typically, those come in some other proprietary format, like either Moxie or JAX-RS and the like. And in Java 8, hopefully, you won't have to do that, and it'll just be a standard API to do that work. Now, having said all of this, the interesting thing that I've often observed is that there's actually good use cases for the low-level JSON Processing API. And interestingly enough, I actually have just such a use case in the cargo tracker application. Okay, and so I'll show you what that use case is and why, beyond sort of serving as a lower level foundation for the Java API for JSON binding, why this API also is valuable on its own right. So let's go back to our cargo tracker application and go back to the bit of code that I skipped. All right. So here's the bit of code that I skipped. Notice that I have a POJO called cargo. This is a domain object, okay, representing the actual cargo object that was updated. Let's take a brief look at this cargo object for a second. It happens to be a JPA entity, and it is a relatively complex JPA entity. Okay, so it has an ID, it has a tracking ID, it has a many-to-one relationship with location as the origin. There's a routing specification, okay, that tells you things like, originally the customer told me this is the origin, destination, and arrival deadline. That's what a routing specification is. It's got an itinerary. That's the thing that I committed to when I chose a route. Okay, a specific way for getting from point A to point B. Each one having its own date, and the actual delivery object to say, okay, this is what happened. Now let's take a look at each of these as well. So let's take a look at the delivery object. It's an embeddable object. Okay, it has things like transport status, last known location, okay, voyage, ETA, handling history, and the like. So what's my point? The point is that this is a very complex domain object. Okay, its structure represents how it should be modeled in the application. It is not a trivial object. On this case, though, when I'm actually generating a update for my client to say, hey, please update the status of this cargo, notice the amount of data that I actually show. All right, it's a very small, relatively flat subset of my entire domain object. So clearly, I don't want to serialize my entire domain object for this entire client. It doesn't make any sense. It's a waste of bandwidth. Rather, what this client needs is a subset of the data. Now, let's approach this from the standpoint of object serialization for a second. So essentially, I need a DTO. I need a data transfer object that I will copy a subset of my entire domain object into to transfer it over the wire. If I was to use a binding API, I'd have to create a specialist DTO just for this purpose. It would serve no other purpose than to say, copy this bits of data into this guy and serialize it over the wire and make sure that the serialization API translates this POJO into its wire form. It's nothing much more than a lot of overhead. All right, so now I have to create a DTO and maintain it. I am going to incur some overhead in terms of reflection to turn this into its wire format. What we can choose to do instead is something like this. All right, so I have a very simple set of data, so why not simply write this data out into a stream? And this is precisely what I do. So what I do is I use the streaming API in JSON and create a simple stream that has just the bits of information that I need. Tracking ID, origin, destination, last known location, transport status. That's it. That's the bit of information that I need. And so to do that, the API looks like this. Okay, so it's JSON.createGenerator, and giving it a writer will give you a stream, okay, for the streaming API. The writer actually in this case is nothing much more than a string writer. I'm just writing directly to a string buffer. You get a generator when you do that. The generator is just a builder API to let you build a JSON payload. Right? In this case, it's quite simple. It's just one object. It's the object that representing a cargo event, and it just has those bits of information in it. And I get those bits of information from the various places in the cargo domain, nested cargo domain object that I need it from. That's it. It's as simple as that. There is no DTO to maintain. There's no overhead of reflection or anything else like that. It's a simple API to give me just a small bit of information from a relatively more complex domain object that I wind up creating a string from in the end, and just sending that string down, JSON string down the wire. All right. And of course, there is the object model API as well. That would be more useful, perhaps in the read phase. Okay, so if you have a relatively complex domain object that you need to navigate in random ways, well, that will allow you to do that. All right. Any questions on the Java API for JSON processing before we move on to the next step? Yes, sir. Mm-hmm.
I was wondering how scalable is this kind of architecture? I mean, if you have to secure that 1,000 sessions will be notified that one event happened in the server, if there is a latency also, then this might take minutes. And if one of these sessions is failing to be updated, then all the others are failing as well, or how is this maintained?
Okay, so there's a couple of different questions in there. Let's answer the first one. So yes, in a WebSocket connection, you're really dealing with a socket, right? So it has so the callbacks again are on, open, on, close. Each of these clients have nothing to do with each other whatsoever, right? In the only commonality may be that in the implementation wise, you're choosing to handle that in a singleton, right? But it has nothing to do with each other otherwise, right? So if one session fails, nothing to do with the other session. You get actually another callback called on error, okay, and that'll give you the session as a parameter. Okay, but that's how that happens. So no problem there really, per se. In fact, even for a given session, if you error out on a single on message, that's not a problem. Right? It doesn't terminate the connection unless you purposely terminate the connection at that stage. Right? So you can get the subsequent message without any issue. Now, the other question you asked though is more interesting. So. In vanilla HTTP connections, those connections are relatively short-lived, right? So that means that you get a request, you're perhaps keeping that TCP connection open for, let's say, 30 seconds or a minute or something, and then you're done doing whatever it is that you're doing. You're closing that connection and returning that thread and the connection, the underlying TCP connection, back to its pool, right? So what that means is that you can serve more clients with a smaller amount of resources, because any given client is going to use that limited resource only for a very limited amount of time. In WebSocket, though, that's not the case, right? Because what's happening is you're opening up a connection and keeping that connection. Now, on the server side, you may wind up passivating that connection. Okay, that's fair enough. But even if you passivate the connection, there's still a file handle open corresponding to that connection. So what that means is you won't be able to serve as many clients, okay, because it's a limited resource that you can no longer share. All right. Is that a problem? Yes, it is potentially a problem. So The good news is, in modern hardware, you can easily scale up to about 20,000 file handles without any problem. Right? You'll run into other issues before you run into that problem. But the reality is, yes, you do have that upper limit of how many connections you can open. That does not occur in HTTP connections. However, it's not a straightforward trade-off. The guidance that I would say is, by default, try not to use WebSocket. Okay, because WebSockets simply won't scale as well as a stateless connection. However, in the cases where WebSocket really is required, you actually will scale worse. Let me explain why that is in a second. So one of the use cases, remember, is high-frequency communication. Right? So let's say an online multiplayer game. In an online multiplayer game, you're doing quite a bit of interaction with the server. Okay, even let alone from the server to the client, but just from the client to the server, you're sending quite a few connections over a period of time. If you were to do that in vanilla HTTP, you'd incur an overhead of opening and closing the connection and establishing the protocol layer, so exchanging the headers and the like, right, each time. So in that case, you'll actually be doing more work both on the client and the server. Right? So in that case, it actually makes sense to incur that overhead only once and then reuse that connection over and over again. So there's a fine balance where it actually does make sense to use WebSocket, but it's a corner case in all reality. Okay. Any other questions? No? Moving forward? All right. Excellent. Moving more into sort of the point releases. So far I talked to you principally about major release stuff and new APIs that were added. Now let's move more into some of the point releases. One of the most important ones is actually Bean Validation 1.1. Okay. There's a small number of things that happened here that are actually quite significant. The biggest one is actually, I'll show you a code example of. It's called method constraints. Right? So method constraints are interesting because they enable sort of contract-driven development at all stages of your application. Previously, in Bean Validation 1.0, you were able to express constraints on Bean properties, and we've seen an example of this already. So let's take a look at my cargo, my cargo domain object. You'll see several Bean validation constraints in here. The biggest one being not null. Let's go delivery. Okay, not null being the most significant one. And you can do more, the size of a field and whatnot. And that has a certain use case. So that's usable in validating data that's going into JPA, validating backing beans in JSF applications. Those are all useful cases for those. Doing validation at the property level. Now, the thing is that doesn't help you when you're talking about method parameters and not properties. Okay, so let's take a look at another example. I have a WebSocket, I have a REST endpoint here. Let's take a look at the REST endpoint real quick. Pathfinder API, graph traversal service. All right. So over here, this is, I'll explain in a second what this is, but for now, just take a look at this. So you have a method called find shortest path. Okay, it takes an origin and a destination, both of which are strings as arguments, and it returns a list of transit paths. Okay, so this is not a POJO per se. Right? This is just it would be possible to validate this at a lower level, but at this point, at this stage, it's simply primitives on a method body. Okay, so can you use, how would you validate this? Okay, the answer prior to bean validation 1.1 is you couldn't directly. Okay, you would have to validate it in some other way. In bean validation 1.1 though, it allows you to do this instead. Okay, so even on primitives, okay, on a method body, you can still express bean validation constraints. All right, so this has a whole bunch of use cases. Actually, one of the use cases is the ones that you're seeing right here. All right, so this is actually if you look a bit farther up, this is a REST endpoint. All right, so this is a path of graph traversal service. This is a get method, okay, to find the shortest path, and in here you can actually express a constraint. All right, you can say, please validate this inbound data, and you can actually also validate method bodies as well. So if you look at another example I have of a REST API, let's look at the handling method of report service. So in this case, actually you have a post request, okay, and the post request has a handling report object. The handling report object, just like in bean validation 1.0 style, has bean validation parameters in its properties, but you can also even validate that. Okay, you can now say, please validate this method parameter that happens to be that happens to have nested bean validation properties in it using this add-valid annotation. Okay, so this is useful in JAX-RS endpoints, REST endpoints. It's useful in WebSocket. In fact, it's useful in any kind of remote endpoint that you have because it allows you to validate your remote endpoints. And it's also usable in the backend in EJB and CDI as well. So you can now, when you're on the server side and you want to validate your API, make sure that your client, your local client, let's say folks that are writing the web tier is actually sending you properly validated requests. Well, you can enforce that in contract-driven fashion using the method level validations. Okay, so even locally this will be enforced. So if there's a bean validation error, in case of a REST endpoint, this will translate into an HTTP error. Okay, probably 400 something error to say, hey, request malformed. Or when you're making a local invocation, this will actually translate into a runtime exception. Okay, if this was an EJB or CDI. All right. There's a few other interesting things that have also happened in bean validation 1.1. The next one is sort of a pain point for folks using bean validation in Java E6 applications. Specifically, when you write custom constraints, which is actually surprisingly common, the custom constraints were not CDI injection capable, which means you can't use the @inject annotation inside of a bean validation constraint. And similarly, you can't programmatically inject bean validation constraints elsewhere in your code. And that comes in handy. So, say you have written a nice validator and you want to programmatically use it somewhere in your business services. Well, you can't use injection to do that. So all of that has now been solved. All of the bean validation artifacts are both injection capable, which means you can use the @inject annotation inside of custom constraints as one example. And you can also inject custom constraints elsewhere into your application as well using the @inject annotation. The other interesting one is integration of EL expressions with bean validation messages. So if you've ever used bean validation, you can express bean validation messages to say, hey, this is my bean validation constraint. If it fails, please produce this message. It used to be that it's just a string. Okay, you can just express it as a string. It's not terribly dynamic. It's a static bit of information that you send to your client. But you can also make use of resource libraries to do that as well. So you do have internationalization capabilities to do that. And this feature takes that a step further, and so you can now actually use EL expressions inside of those error messages. Okay, and that helps create far more custom error messages. So you can get access to anything that's in the environment. Okay, perhaps a timestamp. Or you can write simple Elvis operators to figure out some conditional expression, or you can also have access to the current value that's being validated as well as the constraint itself. Okay, so a bit more nicer error messages. All right, any questions on bean validation 1.1? Yes, sir.
Yeah, you showed the method constraints with these annotations.
Uh-huh.
But wouldn't it fail in the first place to construct the bean that you're passing in? And why do you then even need to put this active validate on the method? If the argument is already annotated with validation rules.
Okay, so the problem here is backward compatibility. So in JAX-RS 1.0, right, yes, in JAX-RS 1.0, and this also applies to other APIs as well, right? When you, in the older APIs, when you have this sort of situation, right, whereas this thing has been validation annotations, nothing is validated, right? So that path would succeed even if you have a bean validation error. If we had said that, okay, now the JAX-RS runtime should automatically reflect all of these method parameters and validate them automatically, well, guess what? When you upgrade this code, right, all of your applications will break. So that's why we needed to have yet another annotation that says, please explicitly turn this on, right, as opposed to just automatically do it. So that's the problem there. Okay. Any other questions on bean validation? Need to go back to my slide deck, I guess. No? We're okay? All right, moving forward. Okay, JAX-RS 2.0. This is principally about improving standardization. So in the JAX-RS 1.0 APIs, what happened was each of the major implementations, so that's Jersey, REST-AZ, and CXF, had a certain set of features that were non-standard. And it happens, just so happens, that all of them actually are common. So the client API is a big one. Each of these APIs actually had a non-standard client API. So the first goal of JAX-RS 2.0 was to make all of these things standard. So take all of the things that are common across these things and make a standard API for them. Same can be said of content negotiation as well. So each of these APIs handle content negotiation slightly differently. In addition to that, add some features that are obvious. Okay, that's obvious in the JAX-RS ecosystem, or more precisely the REST ecosystem. And these would be support for things like asynchronous processing as well as hypermedia support. So let's talk about each of these for a second. Client API, I already talked about the use cases for them. The same use cases that I mentioned for WebSocket also apply here. Okay, so just to reiterate those would be system-to-system communication. Okay, again, this is even more important with things like microservices, where you are actually invoking one Java service from another Java client. Again, testing, right? If you want to test do integration test your JAX-RS endpoint, well, how do you do that? From something like JUnit, again, you need a Java client to do that. And of course, finally, if you have a GUI client that happens to be written in Java. So for all those reasons, the client API actually makes sense. Well, I'll show you an example of the client API. Actually, let's do that right now. So let's go back to our application for a second. Specifically, remember that you could do this routing bit, right? So I still have a not routed cargo. I'll go ahead and click route on it. Okay, and there's the routing information. Now, let's think about this for a second. By and large, this application is relatively straightforward. It's just a bunch of CRUD operations. Okay, there's a bit of business logic, of course. For example, I told you that once we get a cargo event back, calculating its current state is non-trivial. But by and large, this is not a complex, algorithmically complex application. This particular problem, though, is significantly more algorithmically complex. Okay, so we're really trying to solve the traveling salesman problem here. So for this reason, actually, it makes sense for this thing to be a separate service altogether. One of the principal reasons is that the velocity of this service may be different from the rest of the application. And I already said the nature of the service is very different from this application. As a result, the team handling this particular problem may have a slightly different skill set from the rest of your team. So this is actually an example of a microservice. This particular routing algorithm does not happen locally on this machine. The actual resolution of taking a routing specification and coming up with candidate itineraries is actually a separate service. All right. So this separate service is invoked through the JAX-RS client under the hood. This is not a local invocation. This is a remote invocation. So I'll show you how that is implemented. And that is precisely how the JAX-RS client API is used here. So if you look at my services, I should have a routing service. Okay, it's called infrastructure.routing. I'll open that up. It has an external routing service implementation. This is the actually what happens when I say fetch the candidate routes for a specification. So notice the signature of this method. Fetch routes for specification. It takes the route specification domain object as a parameter and produces a list of itineraries. Okay, this actually does not happen locally. All right, so let's take a look at it to see what actually happens. So I get the origin and the destination as strings, okay, from my domain object. And then what I actually do is that I invoke a REST service. Okay, so if you look at Graph Traversal Resource, what I'm actually doing is a get operation. Right, I'm doing a get request on a remote endpoint. As a query parameter, I'm giving it the origin, the destination, and I'm actually saying that I want the request media type to be JSON. All right, so this is a remote HTTP request, okay, being made to a remote endpoint. I'm sending it the origin and destination, and as a payload, I get back, okay, a DTO called transit path. All right, and then I actually translate this DTO into a domain object here. Okay, I copy over the transit path to my itinerary object, but this is a remote invocation, and hence a use of the JAX-RS client API. All right, so if you look farther up, right, the graph traversal resource is left empty here. Okay, there's graph traversal resource. All right, and it is actually constructed in my post construct method for this service. So here it is. It says JAX-RS clients.target, gives it a remote URL, and I'll show you how where the remote URL comes from in a second. It also registers the JSON processors. In this case, I'm using Moxie to do that. But where is graph traversal URL actually coming from? You'll notice in this case, it's actually being injected. Okay, there's the add resource annotation. All right, it's actually injecting the graph traversal URL. It is defined in my jar.xml. Okay, so this is where the graph traversal URL actually comes from. Graph traversal URL, and there's the URL. All right, and I actually can change this URL at runtime because it's a JNDI entry. I can actually override this JNDI entry through the admin console or the AS admin tool to say, hey, for this deployment, please point this URL somewhere else. All right, or I could do it during deployment time. I could override the value of the jar.xml. Okay, so that's the client API. It's actually a relatively powerful API. You saw bits and pieces of it. It also uses the builder pattern, okay, and you can do very interesting things with it. You can do you can run a batch of requests. It has an API to do that. You can do asynchronous processing as well in the client. And you can specify even things like cookies and header parameters. So whatever you can basically imagine in HTTP, it is capable of doing. Other than this, the JAX-RS API, JAX-RS 2 API also added a whole bunch of other things. So it added message filters and entity interceptors. This bears a little bit of explanation. Message filters are basically very similar to servlet filters, okay, only applied with the JAX-RS syntax. Similarly, entity interceptors are similar to CDI interceptors, okay, again, done in a sort of JAX-RS-ish syntactical sugar. So I have a quick question. How many of you have actually written a servlet filter or CDI interceptor? Okay, perhaps about 3-4 people in the room. Okay, the reality is these sorts of things are actually more geared towards the ecosystem, right? So, majority of folks actually, believe it or not, make use of CDI interceptors and message filters. They just don't realize it. Third-party frameworks often that build upon things like servlet, build upon things like CDI, make use of these things. The idea here is very similar to that, right? So this is principally geared towards folks that would build upon JAX-RS. In fact, I have seen a few implementations of entity interceptors and message filters since they have come out, right? But your major thing you need to know here is that it does exist. If you need to do something framework-ish in nature, well, you do have the capability of extending and building upon JAX-RS, but you may also need to register these sorts of things as well. Okay, as more and more folks make these use these APIs to build upon JAX-RS. There's that asynchronous processing support again, and again, this has to do with writing more high throughput reactive applications. Okay, so again, in JAX-RS 2.0, there is that support built into the server and the client. Okay, so on the server side, you have a way of doing asynchronous requests. Okay, so requests that are instantaneously sort of serviced, okay, by giving back the current request thread back to its pool, okay, but doing processing of that connection in an asynchronous fashion anyway. It's similar to the way asynchronous processing is done for servlets, for example. If you're familiar to that, with that, this is going to be very similar. Similarly, again, there is ways of making asynchronous invocation on the client side as well, on the client side API. Hypermedia, let me skip over a little bit, but basically it's a sort of an emerging concept in REST. It allows you to use the concept of hyperlinks within REST applications. It's useful for cases, for example, where you want to write self-describing APIs, okay, where the API actually tells you what do you do next with a given REST request. Finally, I'll describe to you content negotiation real quick. It's an interesting technique, and it's useful for the case it serves. So I'll show you, in order to see that, let's go back to our REST endpoint that I was showing you prior. So let's go back to graph traversal service. Okay. In the graph traversal service, notice that we are producing two different media types. Okay, so notice that there's just one POJO type that we return here. It's a list of transit paths. These transit paths, though, can be produced in two different formats. One is application JSON, and the other is application XML. Typically, you don't have a problem with doing this sort of thing because the client will tell you explicitly what content type they need. Okay, so in my client's example, I said, hey, I want the media type to be JSON. Okay, so even if there is more than one specified, it's no problem resolving which one the server side should use. The problem comes in when you have a client that either can support both formats, okay, or doesn't specify any format whatsoever. So JAX-RS sometimes currently have this problem of, okay, how do I then resolve this? By default, what happens is actually they pick the first one, or they pick it in order. Right, so whatever, if JSON is listed first and the client doesn't tell you anything or tells you that it can support both XML and JSON, it'll typically pick the one that you've listed in order in your list. In JAX-RS 2.0, though, you do get a bit more control over that through something called a QS value. Okay, so if you don't specify anything whatsoever, so you don't make a specification like this one, application JSON semicolon and then QS value something, the QS value by default is assumed to be 1. All right, and 1 is basically the highest priority that you can assign for a QS value. So in this case, what is actually happening is that I'm implicitly specifying the application/JSON to have a QS value of 1, whereas application JSON has a QS value of 0.7, which is lower than 1. So what I'm really saying is, if the client doesn't care, please produce JSON. Okay, I'll show you this in action in a second. So let me pull up Postman, and I'll make a request on this REST endpoint. So you can take a look at it if. Let me see, can I increase the volume? Okay, so as you can see there, I'm making an invocation in the graph traversal service, okay? So in this case, I'm not specifying any data types. So if you look at my headers, okay, I have no headers. I have no content preferences. So if I say send, okay, I'll get I'll get a bit of data, but you'll notice that this data is actually in JSON. Okay, so I haven't specified anything. The runtime chose JSON instead. But let me reverse this for a second. So let's go ahead and say, okay, and I'll do a save. That should wind up in a redeploy. I'll take a quick look at that to make sure the redeploy happens properly. That didn't look good to me. Okay, that was a bit better. I think it's deployed now. So let me go ahead and redo this request. Close this guy up. This end. Uh-oh. Oh, validation failure. Interesting. Very good. So I have a validation failure that I must fix. And I know exactly what it is. Okay. Notice that this is a 6-digit origin that I specified. So this is actually the bean validation values that I have, okay, in my endpoint. That's actually that in action. So I didn't, not on purpose, accidental demo. Okay, so I fixed that, do another send, and as you can see, in this time, I'm getting XML instead. Okay, so just by doing nothing much more than swapping the QS values. And I believe you can actually swap these QS values at the runtime level if you want to as well. Okay, that will, you'll have to write an interceptor to do that, JAX-RS interceptor to do that. But let me change this back in case I want to demo something else and things suddenly are breaking and I'm wondering what's going on. So I will change this back to what it was. Right, and I'm just going to keep my fingers crossed and hope there's no deployment problem with that. All right, any questions on JAX-RS, JAX-RS 2.0? No? We're all okay with with the changes in JAX-RS? Okay, moving forward.
Are we having a break?
Do I actually have a scheduled break?
Are you going to plan to give 3 hours?
Yeah, I was just going to. Yeah, I mean, if you need to go on break, please do so.
We had one in the morning for 50 minutes. So
You did 50 minutes?
15.
15 minutes. Okay, so let's do this. I have, looks like I have roughly about an hour left. How many people want 1 to 15-minute break? Okay, that's fair enough. Let's take a 15-minute break now. All right, excellent. So let's, I guess hopefully you've had a nice break. So let's finish up the rest of this presentation. I'm actually, this is looking good. I think I will be able to cover most of my slide deck, which hasn't happened before with this presentation. It's because you guys aren't really asking me any questions, which I'm not sure is good or bad. Okay, JPA 2.1. What exactly is there? Again, it's similar to JAX-RS 2.2 in some ways. It's a matter of really taking a look at the major implementations and seeing what is it that they have in common that really should be standardized, and a bit of innovation where it was obvious and necessary to do. The first one is an obvious example of just standardization, really. So almost every single JPA provider has this feature called schema generation. What is it? Well, it's simply taking reading the ORM metadata in some way and generating the database schema on the fly during application deployment. It's a bit more than that, though, in JPA 2.1. If you actually take a look at the features that were standardized as part of schema generation, I think it's actually a superset of what every single provider provides. So I'll give you a brief listing of what you can do with schema generation, standard schema generation in Java 7 and JPA 2.1. I'll show you an example of the syntax. It is actually in use in the application. So you can most certainly do the first thing, which is read the ORM metadata, either in XML or annotations, and generate the corresponding database schema on the fly in the database. Well, guess what? In using this feature, you can not just generate the database on the fly. You can also generate the database DDL, data definition language, on the fly. So this comes in useful, if you're developing a prototype application, and at some point you want to give your generated schema to a DBA so that they can further productionize it. Right? So that's one interesting feature. The other interesting feature is that it can actually, JPA 2.1 can actually do the reverse, if you will, of schema generation as well. So you can take DDL statements that were created by your DBA and actually execute them during application deployment. And this is useful for things like development, perhaps cloud deployments. This could be useful as well. And again, you can do a whole bunch of DML type statements. You can either just do a drop or just do a create or what have you. There's various strategies of doing that. Another interesting thing you can do with this feature is actually do the initial population of the database. So you can have it execute DML statements, insert, delete, what have you, also during application deployment. And that's useful, again, for testing scenarios, for doing initial seed data, even in a production application, doing seed data during development and the like. The syntax is very, very familiar. So I'll show you the persistence.xml that I have for this application. It's in other resources, main, meta-inf, persistence.xml. Okay, and NetBeans is having problem opening this XML for some reason. But anyway, this is how the syntax looks like. It's all under javax.persistence.schema generation .database. So on and so forth, right? There's a whole bunch of things available here, right? So these are all of the features that are available. NetBeans will actually tell you will tell you via auto-completion what all of these features are. In this case, all that I'm really doing is attempting to create the database on the fly. What I do in this application is when I load up the application, there's actually a set of sample data that's in the application already. So let me show you the administrative interface. This is all data that is actually inserted on the fly at deployment time. And the database itself is also created on the fly at deployment time. Right? It's useful for doing demos and also for you to get started with the application more easily. So you don't have to write another script to do that. So that's that in terms of the schema generation feature. Again, useful, pretty much useful for anyone using JPA. There's a whole bunch of interesting features there. Stored procedure support. This has been a contentious one for JPA for a long time. Generally speaking, JPA is sort of anti-stored procedure. The entire idea is not for you to be bound to the database. That's one of the things you're getting out of JPA is being able to switch database providers relatively simply. And it's also relatively anti-ORM. In ORM, you're really supposed to maintain your domain model in middleware, not have a whole bunch of business logic and stored procedures. And there's other good reasons why you shouldn't be using stored procedures anyway. But at the same token, this has been a long-standing request from JPA users for a long time. Please add stored procedure support. In fact, almost all of the implementations have stored procedure support in one way or the other. Now in JPA 2.1, it is finally standardized. Okay, the syntax looks very similar to native queries and native named queries specifically. So not anything too terribly difficult. Unsynchronized persistence context, I won't talk about this in great detail. Let me briefly describe what it is. It's to solve a particular corner case. So let me describe what the problem is. By default, persistence contexts in Java EE applications are actually synchronized with the transaction. So whenever you do a transaction commit, the changes in the database are automatically, in the entity manager are automatically committed also, flushed to the database as well on commit. There are certain use cases where you don't want this to happen. So for example, if you want a bit more programmatic control and you have a set of changes that you want flushed, so you do a manual flush of those changes, but you don't want all changes flushed during a database commit, well, you can set the persistence context to be in a special mode called the unsynchronized mode. In that particular case, the persistent context will essentially ignore the transactions altogether until and unless you specifically say, hey, persistence context, please explicitly join the transaction now. There's actually a method called persistence context entity manager.join, okay, join, and that will actually rejoin the transaction and resynchronize transactions with database flushes. Okay. Entity graphs. This is actually, in my opinion, probably the most important thing that was standardized as part of JPA 2.1. Let me explain the problem and let me explain what this feature actually implemented. So this is a feature actually that has existed in TopLink for a very long time. In fact, probably for the better part of 10 years. Let me describe what the problem is first. In JPA applications, there's actually really two ways of handling data load, either lazy loading or eager loading. You specify the configuration for lazy versus eager loading at the domain model level. Okay, so the domain model itself will tell you, okay, this bit of the domain model should be lazy loaded versus eagerly loaded. The problem with this is, though, is that this works for relatively simple use cases, perhaps even a majority of use cases. However, if you are writing complex enough queries in your application, there will be always a case where your data load is so specialized that it has a significant mismatch between what you have specified at the domain level. So you will either wind up, for those types of complex queries and complex use cases, you will either wind up doing unnecessary lazy loading or eagerly loading a whole bunch of data that you do not need. All right? Now, is there a solution to the problem in JPA 2.1, in JPA to do that? Yes, there is. So for example, in JPQL, you can do what's called an eager join, right? And eagerly join a particular use case. But beyond this, though, there is no declarative way of doing that today. That's where entity graphs come in. So in entity graphs, what you can do is you can specify your exact loading strategy. You can say, this is my entity. For this particular entity, please load this bits of data. Okay, please eagerly load this bits of data and ignore the rest. And you can do this in two different ways. You can either do it additively, so apply these sets of what's called a fetch plan, in addition to what you already have specified at the domain model level, Or you can also say, please ignore whatever is in my domain model level and just execute exactly what I am telling you. This is exactly what is called an entity graph, right? So this basically gives you what type of flexibility you would have by handwriting SQL statements and handwriting joins while still giving you the productivity that comes out of an ORM tool. So if you haven't looked at this entity graph feature yet, you definitely should be doing that. Entity converters are also another important feature for a particular use case. So entity converters, think of this as AOP, or rather interceptors for JPA 2.1. When is this useful? It's by and large useful for data conversion. So often when you're dealing, especially with legacy code bases, you wind up with a scenario where the way that the data is stored is not really represented in the way it is in your domain model. So you wind up writing sort of a bit of translation layer in your DIO or repository code to handle this. Right? So and this code is sort of all over the place. You know, whenever you do an insert, whenever you do a delete, whenever you do a select, you have these little bits of conversion code to deal with data synchronization format idiosyncrasies. The worst one that I've ever seen in my life is actually there's people storing relational databases, relational data, in a relational database, but then they use this one crazy field that's usually a blob or a text field, and they'll actually store delimited data in that one field, right? So they'll with a comma separated or semicolon separated data in a text field, and then they'll convert back and forth from their entity model and so on. And imagine this sort of code all over the place in your repository or DIO code. So what entity converters allows you to do is basically write an aspect to put that conversion code, write that conversion code once in one place, and then apply it in a declarative fashion. Okay, so you say, for this set of fields, or this one field, please apply this conversion logic whenever you see it. Okay, it could be as simple as you have some textual data in your database. You want to apply a simple transformation to better represent it in your Java code. Okay, JSF 2.2. Honestly, it's got a lot of stuff in it for JSF users. It's really quite a valuable release. I'll explain a few of these and talk through, maybe show you a few of these in the code as well. First and foremost, actually, is HTML support, and this is a surprisingly important one, even if you're not using HTML5. So by and large, using HTML5 with JSF is not that complex. So a whole bunch of features that are HTML5 are really orthogonal to JSF markup. So these would be things like Canvas, the Canvas element, or web workers, or what have you, right? So they have nothing to do with JSF markup. They're sort of their own island, if you will. However, there are some cases that changes were made to the forms themselves, or new form types were introduced as part of HTML5. One of the big ones is things like default value, right? So you can have a default value for a field, and that's actually universally applicable to all of the existing forms, even text fields. Some other interesting forms are new forms, were things like time and email and date time and the like. So with JSF, usually how you produce JSF HTML components is that you produce the JSF version of it, the JSF markup version of it. There's actually some benefits of doing that. So when you actually use a JSF version of an HTML input type, JSF does much more than simply render a simple HTML input type. It'll actually make sure that that all of the JSF supported features are cross-browser compatible as well. But it still poses a problem in terms of JSF continuing to catch up with these new HTML types as we move forward. So what the what the JSF-EG decided to do instead is actually allow you for the first time to use just vanilla native JSF components, okay, and allow and add markup to it. Now, I've made some recent changes to the application, but let me see if there's a place where I can actually show you that in action. Is there still, there's not that. Maybe in the, let me go back a second. Do I have that in the public tracking interface? No, I don't have that anymore. I used to use HTML5, actually native HTML5 components to do some of these things in a prior version. I did a look and feel update, and I actually wound up removing all of them and using prime faces components instead. So I won't be able to show you that code, unfortunately. So this is a bit of a faux pas on my part. But basically, what you do in that case is you attach the JSF parts like ID and rendered and a value binding, and you declare that in a separate namespace, just like you do in almost everything in JSF. And then what you can do is you can say something like input type text, just like you would in raw HTML, and then you can say, this JSF namespace : value. And then what you'll really wind up doing is treating this native HTML tag as a JSF markup. And that's actually helps solve one more complaint that some people have with JSF, and namely that I can't give my JSF markup to a designer because the designer doesn't really understand what all these JSF tags are, whereas they understand their HTML counterparts. So now you can do so in JSF. You can just write plain JSF code, and attach it to JSF where you need to using a custom namespace, and then your designer can have something that looks just like what he or she is used to looking at. Another very important one that I actually do have an example of is alignment of CDI and JSF. There's actually a few different ways that has happened. One of the big ones is that there was a separate scope called the view scope in JSF. It was a JSF specific scope. What the view scope allows you to do is have the component lifecycle be active during the initial request and one more subsequent request. So a good example of this is, for example, my Finder page here. So on the initial request, I have a backing bean that's going to hold my tracking ID, and if I enter some values, so DAF789, well, on the subsequent request, that value is still bound. Okay, so this JSF managed bean is still alive now, but no more after this. Okay, if I make another subsequent request, it's going to be another bean. And this is exactly what the view scope is designed for. So it's a very incredibly useful scope that was bound to JSF. So you couldn't use it with CDI managed beans. So now there's actually a CDI compatible view scope bean that you can use just with CDI and nothing to do with JSF managed beans at all. In fact, JSF managed beans as a whole has been deprecated. Okay, so the JSF-AG, if you read the JSF spec now, will say don't use the old managed bean model. Why is that? It's because to streamline the platform a bit more. So we have a whole bunch of overlap with JSF managed beans and CDI. They do some very similar things: scoping management here, scoping management there, dependency injection here, dependency injection there, lifecycle management here, lifecycle management there. So now you're basically encouraged in the Java E platform to just use CDI as your backing beans. Or if you're using some other dependency injection mechanism, then just use that. Don't use the JSF managed bean model. In fact, we're trying to do the same things with with other APIs as well. So for example, this could also be done for EJB as well. We could just consolidate everything to CDI as opposed to maintaining these two separate parallel component models. Another new scope that was introduced, let me show you an example of view scope. Very simple. I just need to open up my public tracking interface, and here it is, track.xhtml. Okay, if you look at what is going on behind the scenes here, here's the tracking ID. Okay, so there's the tracking ID binding. Right, there's a value and the binding for the tracking ID, and when I hit submit, okay, here's a command button called track. We're invoking this onTrackById method. If you look at the track object, all right, it's simply named and view scoped. Okay, so this is a CDI managed bean essentially. All right, so you can do this previously. This had to be a JSF managed bean in prior versions of JSF. Okay, JSF also introduced another very interesting and very useful scope called the flow scoped. Just like the view scope, this is actually not available in JSF managed beans at all. This is only available for CDI managed beans. What does it do? You can think of flow scoped as essentially garbage collection for web applications. Let me explain that statement for a second. If you look at the average web application actually is separated into distinct sections, generally following your navigational breadcrumbs. So in an e-commerce application, you'll have a catalog browsing component, an ordering component, a user management component, and the like. What tends to happen is that component lifecycles live and die within these silos in your application. So when you're doing catalog management, you'll have a specific set of beans that you'll work with. When you're dealing with user management, you'll have another set of beans that you generally work with. What the flow scope allows you to do is declaratively define the lifecycle boundaries for those components. So you can say that here is a scope that is only valid for the user management section of my website. So what that means is when I exit this section of my website, delete, automatically remove the beans that were alive, during that section, marked to be alive during that section. So this gives you something essentially in between the extremes of a request scope, okay, which is only available, for a given request, or a view scope, just an extended request scope, if you will, and the session scope, which is alive during your entire session cycle. So this is sort of, think of it as a truncated session specific to a web application. It's actually also an incredibly useful scope, especially for applications that are heavily workflow driven. Stateless views are an important optimization technique for JSF. JSF applications, because of the fact that it's a true MVC framework, what JSF does is that it creates state where state wouldn't exist. Okay, so it does that by saving the UI tree behind the scenes, at least for a few requests. Okay, that's how you get these nice features like not having to write a controller whatsoever. Just being able to do data binding and event handling, being able to come back to a page and have it restored back to the state that it was before you left it. These sorts of nice features happen because of that state management behind the scenes. However, if you have an application, a page that doesn't need that state, okay, so if you can just get by request scope and nothing else, you're not using flow scoped or view scoped or session scoped, you can now mark that particular page as a stateless view, okay, in which case JSF will actually not save the UI state for that at all. All right, which will save you a little bit of time in terms of memory. Questionable whether this is really advisable or not and how useful this is, but it's an optimization technique that's there for you. If you want to make use of it, it's now available. Resource library contracts are essentially themes for JSF. Okay, so what you can do using resource library contracts is essentially demarcate a set of resources. So this would be CSS, JavaScript images, and package them in a certain way. You can say this is a set of resource libraries that I want to use for this application. And instead of statically referencing those resources now in your main application, you'll make a logical reference to those resources. What this enables you to do in the end is being able to swap resource libraries at runtime. Okay, so you have one set of resource libraries, another set of resource libraries, logical connections to each. You can say, now use this set of this resource library instead of this one. And you can do this swap either statically at configuration time or dynamically at runtime. Okay, so this is useful for doing things like switching client views, right? So if you have a SaaS application, that's being used by multiple clients, well, you can swap the look and feel of your application for that given client. Okay, or just for giggles, you can also have them change their own theme, and customize themes if you wish. View actions are an important one, and actually I'm using view actions to render this particular page. So if you go into the administrative interface, this is actually, this is not using view actions. This is using view actions, okay? So if you look in the detail page for a bit of cargo, you'll notice that I'm feeding it the tracking ID. If you look at the URL, okay, there's a tracking ID equals ABC123. I actually programmatically set that in the page. In JSF, usually it's difficult to do this sort of thing, right? In JSF, you either can load a bit of predefined static data quite easily, or you can handle a response, okay, quite easily. But there's this other use case of navigability. So it may be the case where I have this URL, a bit of information that I pass in the URL, and I want to bookmark this bit of information. So that is where view actions come in handy. So let's take a look at the show.xhtml, so I can tell you what actually is going on here. So this is under admin. Show.xhtml. And at the very beginning of this page, you'll see that I'm doing a fViewParam tracking ID, okay, and I'm binding it to cargo tracking ID. So whatever the URL parameter is of the name tracking ID, I'm binding it to my backing bean, okay. And then I also have a pre-render view listener that actually loads this information. All right, so I'm loading this bit of cargo, looking at the tracking ID here. This actually, believe it or not, was surprisingly difficult to do before JSF 2.0. Okay, there was various Mohara-specific or MyFaces-specific ways of accomplishing this. So now this behavior is standard in JSF 2.0. It looks like I'm actually running out of time, which is not surprising. I will simply talk over the rest of the slide deck. I won't actually show you the rest of the code. So let's now move on into batch applications for the Java platform. Why was this added? This addition of this into the platform is actually a reflection of how successful Java is and continues to be. So by and large, when you look at Java applications and server-side Java applications and application servers, by and large, this is really nothing much more than sort of web servers on steroids, right? That's by and large what they do. They produce web applications. In reality, though, most of the mission-critical, a lot of the mission-critical work in the world does not happen in this online world. It actually happens in the offline world in very old code written in things like CICS and COBOL. This is offline batch processing. So it's perhaps cases where organizations like banks or insurance companies have a bunch of data that they accumulate over a period of time, and then they process this data, move it from one place to the other, do interesting things with it offline, okay, perhaps overnight or in a certain against certain events. What we've seen, especially in the last 5 years or so, is that a lot of those old applications, there's actually a real desire to write those applications in Java. In fact, if you look at this, the folks behind this standard, it comes from a very surprising source. The folks that led this spec is actually IBM, the same people that are making money from these old COBOL and CICS applications. So that tells you, that there is a real desire to do these things in Java. Now, the other nice thing about not just in Java, but standardizing this as part of Java EE is that you can actually now use the Java EE platforms, the existing installations of the Java EE platform runtimes that you have, not simply as just glorified web servers, but actually backend servers that do this offline transaction processing. In addition to that, you are getting a whole bunch of things that you otherwise would not if you are, for example, writing this in Java SE. So these Java EE platforms already have built-in capabilities for scalability, clustering, load balancing, thread pooling, resource pooling, security, class loading, and the like. So you're getting all of those features, in a batch application infrastructure right away. In addition to that, if you look at, for example, the WebLogic implementation of the batch application platform, if you look at the WebLogic console now, it actually has a separate section now for batch jobs. It will list the currently running batch jobs. You can start and restart your batch jobs from the WebLogic console. You can take a look at the history of the given batch job and the like, and it will also do live monitoring of your batch jobs. So incredibly important, and really a whole new dimension of how you could really utilize your Java EE bits of infrastructure. Because it's from IBM, they actually have standardized the most common things that are well understood for a long time in batch applications. So these are things like batch operators, things that do start, restart, and stop of jobs. Repositories to make sure that you have a space where runtime history is stored over a period of time. Jobs and steps. This is how you generally structure batch applications. A common pattern in batch applications is what's called reader, processor, writer. That's what you do. You read one record at a time, you process them, and then you write in batches. That's how generally how the batch workflow works. All of these patterns are baked into the Java API for batch processing. When you're essentially using this API, you're automatically buying into a whole bunch of paradigms and well understood patterns that are applicable to batch processing. There are other features on top of that as well. So these are things like chunking. So what this means is if you're, let's say, processing 1 million records and you have a failure in record number 10,001, well, guess what? You're not failing all the prior 10,000 records. What happens with chunking is you fail and succeed in small chunks. Okay, so you write perhaps chunks of 10 or chunks of 15. So that's your failure unit. Checkpointing is related to that. Checkpointing is basically the mechanism by which you say, this is where I am now in my long sequence of batch jobs. There's ways of handling transactions, retries, exceptions, and the like. There's also concepts of workflows, batch workflows. So it may not simply be a flat job. You may have an entire workflow that you trigger off. Also parallelism. Okay, so all of these things again are built into the batch application platform. There is actually a batch job in the application itself. I'll show you that. I won't have time to show you the code, but at least I can show you the mechanics of it. if you see, there's a batch job behind the scenes running that is basically scanning a directory called temp uploads. So all of those events that are that you can register one by one using the mobile interface, well, you can also register those as a file. So you can have a whole bunch of them in comma-separated format, and you can upload them to a certain directory, and this batch job will run and process those in a big batch. How can you look at this code? It's actually very simple because of the way that the application is structured using domain-driven design. So it is all under this directory, okay? It's called Cargo Tracker Interfaces Handling File. So all of the large number of batch artifacts are in there. You'll be able to figure out what is going on in the application by looking at that. The last one that I want to talk about is the Java concurrency utilities. I don't have that much time left, so I'm going to skip right over to the code example. Okay, so Java EE has a whole bunch of ways that it allows you to do asynchronous processing. I cover a lot of these in my reactive Java EE talk, which if you Google around, you'll find that talk. Either it's slide deck or it's video. But there are some specific cases where you do want to use lower level threading semantics, like the runnable object or the thread object. These are cases where you have very, very fine-grained workflows that you want to create a custom work manager, okay, where you specify these are the amount of threads that I want in this pool. This is what I want the timeout of this thread pool to be. This is a long-running thread. All of these are going to be long-running threads. These are going to be low priority, and so on. So if you have those particular needs, you need to use the lower-level thread semantics or runnable semantics. It isn't easily possible in a higher-level declarative semantics. There may be another case where, again, you don't have a custom workload, but you have a sort of this one-off thread that you need very tight control over. Okay, you want to monitor it and give it a specific name. Again, priority. You want to set priority, set timeout, and the like. And also, a lot of third-party APIs that run on the Java EE platform need to spawn their own threads. They can spawn Java SE threads, but those Java SE threads are outside of the Java EE runtime. So they can't make use of monitoring features that's built into the application server. They can't use the application server's thread pool. They run in an unspecified security context and the like. So you needed some API that allows you to run low-level threads inside of Java EE in a safe and reliable way. And that is basically this API. It's really nothing much more than the Java EE version of Java SE executor services that are already there. So in order to get a handle to this, you simply inject it. You say add resource, manage its executor service. And then instead of spawning a new thread object or creating sort of your own custom Java SE thread pool, all you really do is that you configure the manage executor service the way you want it, and you submit your runnable object there. Okay, so in this case, I'm simply submitting a runnable object in this case. I could be using lambdas here. I'm not, but you could do that to improve the syntax even further. There's a whole bunch of other things that I won't cover in the limited time span of this talk too much. So in JTA 1.2, we began sort of parsing out some of the EJB features and making them available in CDI. Transactional is a good example of that. I actually do have a usage of transactional in the application. If you search for the transactional annotation in the application, you'll find its usage. In EL 3.0, the big thing really was decoupling the EL 3.0 API out of JSP and making it available standalone. This is what is enabling us to make use of it in other places like bean validation, or even in Java E8, we may be using the EL expression API in the security API. We couldn't do that until we decoupled it from JSP. So that's a big one. And there were some other things that actually improved the power of the EL expression language. So now you have support for lambda expressions instead of EL. You may use those if you so wish. There's better support for more operators. There's better support for collections and the like. In Servlet 3.0, principally it was about enabling the WebSocket API. WebSocket under the hood uses Servlet 3.1. So it needed to be completely needed better support for non-blocking I/O. In order for that to occur. So that was a big change there. There's also better support for upgrades to again enable WebSocket and the like. CDI 1.1, the biggest change was global enablement. It used to be that you needed this artifact called the beans.xml to enable CDI. Now you don't need that. Basically, CDI is enabled by default. There was a few other minor changes and bug fix type things that are also in CDI 1.1. CDI 2.0, which is now being worked on, is actually far more and has much more scope. I think somebody mentioned truncation. So yes, one of the things we truncated this time on was CMP, a container managed persistence. Very old stuff from EJB, Entity Beans 2.0 era. And also BMP, Bean Managed Persistence. That's yet another EJB2 Entity Bean stuff. That's been truncated in Java E7. Okay, so all of that done. Let me again point you to the resources, remind you all of the resources that you can use going out of this presentation. First and foremost is the Cargo Tracker website. Okay, it's simply you can reference this way, java.net projects cargo tracker, or a much more simpler URL is simply cargotracker.java.net. Okay, again, it'll tell you a whole bunch of information about this project. You can go and download this, the source code yourself, set it up yourself, and you'll be able to see the Java EE7 code in action on your own. I've given you my slide deck as well. Again, all you need to do is look at my Twitter stream, which does change very frequently, I must admit. But I'll try not to tweet and retweet too many things for a little while, because you can go and get the PowerPoint version of this slide deck, of the PowerPoint slide deck. Remember, it has all of the speaker notes in it, right? So even the resources page has speaker notes to describe all of the things that we talked about. So you can definitely use that as a resource. I also tend to write trip reports. In fact, I always write trip reports for every single event that I go to. I've been a bit behind on the trip reports, but in the worst case scenario, if you don't download the PowerPoint now, I will I will point to where the source for this deck is in my trip report. Hopefully that's no more than a month away from now. So you also have that as a resource. Beyond this, you have a whole bunch of resources really to learn Java E7. The Java E community has been very good about blogging about pretty much anything and everything that is in Java E7. A good place to see how that is the Aquarium blog. Okay, so if you read through the Aquarium blog, which is blogs.oracle.com/theaquarium, you'll get a feel for how much people have actually written about Java E7. And certainly the Aquarium blog itself is also very useful. I and a colleague of mine, his name is David Delabasi, we try to blog about something almost every day. Okay, so it's a good way to stay engaged and stay up to date with what is going on with Java EE, certainly. There's also a whole bunch of good books written, a whole bunch of, at least 5 good books have been written on Java E7 already. But there's also a 100% free resource that I always recommend. It's the Java EE tutorial. You can get it in book format or PDF format if you want. But it's just freely available online, and it's a good high quality resource. Definitely recommend that. There's also some things where you can just learn hands-on. Okay, so one of the first ones is something that is part of the Java EE tutorials called the first scope application. Basically, this is a tutorial that will take you about 2 or 3 hours to complete, but it will give you a realistic view of how it is like to develop a simple Java EE application. It uses a little bit of Java 7 here and there, but it's mostly just a vanilla Java EE application. There's also the Glassfish official hands-on lab that deals with Java E7. It will take you about 7 or 8 hours to complete. It is designed to be self-driving. Okay, you can log on onto this website. It has all of the resources you need to do this lab by yourself on your own time. What this does is that it takes a Java E6 application and adds a whole bunch of Java E7 features one by one. Not all, but a whole bunch of them. And that will also give you another view of what is in Java E7. Beyond this, there's always, if you want to get involved in the specs, there's always a good place to do that is javaespec.java.net. And of course, you're always welcome to use the Glassfish community as well and use Glassfish to sort of explore Java E7 and Java EE generally. And that's always available at glassfish.org. Okay, so thank you very much. I think we're pretty much done with Q&A. I'll stay in this room for 5 more minutes if you do have any Q&A. I appreciate your spending 3 hours of your day with me. I hope you got something out of it. Certainly, I enjoy doing this presentation. It really gives me a chance to talk about the things that we've done for Java 7. Thank you very much.